Hello. And this week's Fiddler is an absolutely classic puzzle. A variation on this puzzle was actually featured in the third Die Hard movie, although that movie kind of edits out the most important part of the solution. So it's not much help in figuring out how the puzzle works, although there are countless articles online to talk about the solution to this particular puzzle, partly because of its fame in the movie. But we're going to try to go a little bit more in depth and think about some of the deeper math behind this puzzle. And if you've been watching my Sudoku solves, you may guess that this involves modular arithmetic because it's going to be kind of a theme this week. So anyway, here's the puzzle. The puzzle is that I have two jugs, and I've got a big jug which can hold 10 gallons of water, and I have a small jug which can only hold 3 gallons of water. The goal here is that I want to use these jugs so that one of them has exactly 5 gallons of water in it. And there are only 6 things I can do, right? So I can fill up a jug to full, and I can do that even if it is missing some. I can transfer water from one to the other. So I can transfer 3 gallons from the big jug to the little jug, for example. And I could fill it up again if it's halfway full. That's totally fine. I can empty a jug, right? Get rid of all the water, get rid of all the water from either jug. Right, I can fill either jug and I can transfer the contents from one to the other. And those are basically the 6 things that I can do. For either jug, I can fill it, empty it, or transfer the contents. And the transferring, there's a little bit of nuance to it, right? So if I can't complete the transfer, it'll basically go as far as you can until something fills up or something empties. So for example, maybe I do one more transfer over here. And now if I fill up bucket B, the small one, I can then try to transfer, but there's only 1 gallon of space left on the left. So if I transfer over, 1 gallon will shift over, and I'll be left with 2 gallons over here on the right side. And even just playing around with it, you may have already figured out how to get to 5 gallons, but I want to basically show that the general method here, which is that the only way to make any progress in this puzzle is to do essentially one of 2 strategies. I can either fill up the big jug, right? And then slowly take water out of it with the smaller jug, right? So I can transfer it over and then I empty that jug, right? Transfer it over, empty it, transfer it over. And I can keep doing this. And then when the big jug empties, I can fill it back up and then keep going, right? And that's one way to make progress and get kind of interesting numbers that are not just, 0, 10, or 3. I can keep doing this process and I can basically get any number I want if I just continue this process over and over. The other way that I can make progress is to fill up the small bucket and dump that into the big bucket and just do that over and over again until the bucket fills. And then when it fills, I just empty out the big bucket and keep going. And similarly, this method will get me any number that I want. It just, how many steps it takes is kind of the fundamental question. And what does this have to do with modular arithmetic? Well, basically, when I do either of these methods, what I'm doing is adding or subtracting 3 being the size of the small bucket, and I'm taking a mod 10 approach here, meaning that whenever this bucket fills up or empties, I kind of either empty it out or refill it back to 0, and then I kind of keep going, right? So as an example, right, if I fill this up 3 times so that I have 9 in here, 9 plus 3 should be 12, but if I complete this process and fill it over instead of 12, what I'm left with is actually 2, because if I take 12 mod 10, that 10 goes away and I'm left with only 2 gallons left. So why is this the only thing that works? Well, it's hard for me at least to prove something like this, and so here you can see that I have 5 gallons here. It takes 12 steps, which happens to be the optimal path here. But how do I know that I can't do anything else? Well, let's consider, I wish I could just go back one step, but let's just consider, let's say I'm like here, right, in this process of filling up buckets. Well, what are the things that I could do? I could fill up bucket B, which is what I do in the process, so let's ignore that. I could empty out bucket A. That seems silly because I just spent a bunch of steps filling it up. I could fill bucket A, meaning the big bucket, But that again seems silly because I spent all this time filling up with smaller amounts. If I fill it, I could have just, from the very beginning filled it up in one step. So there's no real point in filling it once we get there. I could transfer back to bucket B, but that's just going back a step essentially. And we're exactly where I were at step 5. So there's no point in really doing that either. So once you're kind of on this path, there's really only one way to progress, which is to keep going along this path. And there's really no shortcuts you could take at any point to circumvent this, at least as far as I can tell. If there is a shortcut, please let me know because I would be very interested to see that. But at least from what I can tell, there's really only these two paths, and any kind of deviation you make from this path is just going to slow you down or repeat steps unnecessarily. So how many steps is this going to take? Well, again, there are two ways to go through this. So let's do it by filling up the big bucket and taking water out. So I get 3 gallons out here, empty the bucket, take 3 more gallons out, do that again. And then now when I fill this up, my bucket still has some space in it. I'm not going to empty it. I'm going to fill bucket A, right, and transfer it again. Now I have 8 gallons left here. And when I empty it and do one more transfer, now we're at 5 gallons, and that takes exactly 12 steps to get there. Now, if I go the other way, right, I can do it the other method. I can fill up the small bucket, transfer it over, keep doing that 3 times. And now when I try to transfer, there's kind of a little bit too much in the small bucket to transfer over, so I have to empty it. And then I can transfer over again. And again, in 12 steps, I end up at 5 gallons. Now, the fact that it's the same, I don't think that's a coincidence. 5 is kind of the center of this modular sequence. But the thing to note before I get into what that modular sequence is, you maybe notice that if we want to calculate how many steps it takes to get to a particular number, well, first we need to figure out what is the fastest way to get there. But whichever way I end up going, basically, anytime I go from 10 to 7 or 7 to 4, anytime I'm going to go up or down by 3 gallons, it essentially takes 2 steps, right? So at the beginning, it takes 2 steps to fill this up, or 1 step to fill it up, then a second step to get down to 7, right? And then I use a step to empty the bucket, and then another step to get down to 4, right? Again, another step to empty the bucket, and another step to get down to 1. So it takes kind of 2 steps to go along this process, unless you're going around 10, 0, right? Unless you're using this modularity here. And when that happens, it takes 4 steps, right? So here, if I want to do it again, well, I empty the bucket, that's 1 step. I transfer, that's the second step. I fill it up, the big bucket, that's the 3rd step, and I transfer again, that's the 4th step. So to go from 1 to 8, where I circle around 0, that takes 4 steps, not just 2. There's one special exception here, but I'm gonna save that for the very end because it's kind of a little trick in the extra credit. But that's kind of the basic of how this process works. So what do I mean by this modular cycle? Well, I basically mean that I can get this pattern where if I start at 0, I can go up by 3, and if I wrap around 10, right? So I'm going from 9 to 2, that's just adding 3 mod 10. And I keep going on this cycle. I'll end up back at 0, but I'll get every single digit in between, right? You'll see I get 1, I get 2, 3, 4, 5, 6, 7, 8, and 9, right? I get every digit in the way. And the reason I get every digit is because 10 and 3 are what's called relatively prime. I'll talk more about that in a second. But in this case, I'm going to get every digit between 1 and 9, or 0 and 9, I guess, essentially. And then the pattern repeats. And if I'm subtracting 3, I'm just going the other way, from 0 to 7 to 4, etc. And 5, I don't think it's a coincidence. 5 is exactly in the middle. So it takes 5 steps in this cycle to get to 5, whether I'm coming from the left and going up, or I'm starting at 10 and going down. Either way, it's going to take 5 steps to get to 5 here. And so how many steps in the jug pouring game is this going to take? Well, if I go to 0 to 3, like I said before, that's going to be 2 steps. Now, if I just needed 3, I could say I do this in 1 because I could just fill up the small bucket, and then that's it. But since I know I'm going to need to get that water into the big bucket, I'm just going to ignore that for the time being and say, look, that to get 3 into the big bucket takes 2 steps. To get 6 into the big bucket takes another 2 steps, right, and so forth. So by the time I get to 9, I'm up to 6 steps. And Here's the special asterisk here. To go from 9 to 2, it's going to take 10 steps. And I'll talk about what that asterisk means at the very end. And to go from 2 to 5 then is another 2 steps. And now I have 12 steps total. Whereas if I go the other way, right, 0 to 7, it's the exact same process. 0 to 7 is 2 steps, to 4 is 2 more steps, 2 more steps to get to 1. 1 down to 8 wraps around 0, so that's going to take 4 steps, and then back is 12 again. So because 5's in the middle, and either way I'm wrapping around once, which kind of has to be the case because to go from 0 to 0, I'm going to have to wrap around twice, and so I'm going to wrap around once before the midpoint and once after the midpoint. But either way I go around, I'm wrapping around once, I have 5 steps, so I end up with 12. So another way that you could actually think about this is to say, well, 5 is the 5th step from 0 in this modular series, so I'm going to need to fill up the small bucket 5 times, and that's going to take essentially 2 steps each time. And where does this 5 times 3 come from? This is, I'm going to end up with 15 total gallons that I'm filling up here, right? 5 times 3, I'm filling up the small bucket, which is 3 gallons, 5 times. So there's essentially 15 gallons going through this puzzle. And so each time I fill up that small bucket, that takes 2 steps. So that's 10 steps total. And then because I end up with 15 gallons, that means I'm looping around once because 15 is between 10 and 20. So that's going to be one extra modular loop. And so there's an extra 2 steps there for a total of 12. Now for the extra credit, instead of having a 10-gallon bucket and a 3-gallon bucket, we instead have a 100-gallon bucket and a 93-gallon bucket. But the principles are exactly the same. The math is a little harder, but everything is pretty much the same. But the question is actually not how many steps does it take to get to a certain number, but what is the hardest number to get to? Hardest meaning takes the highest number of steps. And how many steps does it take? So the modular cycle is very similar, right? If I'm going up, it's 0, then 93, and then I add 93 again, it actually goes down because of the modular arithmetic, but I am going up. I'm increasing by 93 at each point in the cycle, right, 0 to 93 to 86, et cetera, et cetera. So the question is, how many steps are there between zeros? And what I mean by that is, like, how long is this modular cycle? Well, this goes back, I need to discuss a little more about what relatively prime means and why it matters here. Right? Because 93 and 100 are relatively prime, every number is going to be visited in this space. And so I can make a whole 20-minute video explaining why this is true, but the basic intuition here is that if I'm adding 93 over and over again, in order to get to 0, because 100 is relatively prime from 93, the only way to do that is I'm going to have to basically add it 100 times. So I'm going to have reach 100 different numbers before I get back to 0. And just because of the way this modular arithmetic works, there's no way to repeat numbers. And once you repeat a digit, you're stuck in a cycle and you'll never get out of that cycle. And so you can't, once you're in that cycle, you can't have a new digit. And so since I have to have all 100 digits in the cycle before I get to 0, and I know I will get to 0 if I just do it 100 times, then I have to reach each digit exactly once before getting there. And by relatively prime, essentially what that just means is that if I think about the prime factors of 100, it's just 2s and 5s, right? It's, how many was that? It's 2 5s and 2 2s, I guess, right, because it's 10 twice. And 93 is not divisible by 2 or 5, so there are no 2s or 5s in the prime factorization of 93, so these digits are in fact relatively prime. Anyway, this just means that I'm going to get every number between 1 and 99 on this chain. So if I don't include the zeros, that's 99 steps. And I want the midpoint of this chain, which is going to be the 50th step. What is that number going to be? Well, it turns out it's actually going to be 50. And the way you could calculate this is I could take 93 times 50 steps. It's going to be 4650. Take mod 100 of that. And that means get rid of the 4 and the 6. And I'm just left with 50. Not 50 factorial, just 50 excited. And you could just say, well, I could just think about this problem symmetrically in the same way that 5 was the midpoint of the mod 10 cycle. Here, 50 is going to be the halfway point of the mod 100 cycle. And I mean, you could justify this by saying, well, look, if I double it, whatever is the midpoint, I'm going to have to end up back at 0 or 100. And so it only makes sense for it to be 50. And so that would be another reasonable way to get to 50. But how many steps does it take to get there? And that's where the trick comes into this problem. I mentioned an asterisk before, and we'll get there in a second. But the naive answer here is to say, well, let's take a we're gonna have to fill our bucket 50 times, right? And each one, because we're going to the 50th step in this chain, and there are two bucket steps for each fill. So that's 100 steps there. This math up here gave us 4650, so I know I'm looping around the modular 46 times, so I need to add 92 more steps. And so you might think, okay, so it's 100 steps plus 92 steps for 192 steps, right? This is actually not quite right. And this is a little trick here they did at the end to maybe fool a couple people. And here's where I want to go back to our jugs and show you why there are situations where if you're just trying to get to a certain number, you may not want to rely directly on that math. And so you may remember that the number 2, if I wanted to figure out how do I get 2 gallons in a bucket, that had an asterisk in it. So why did 2 have an asterisk? Well, let's go through the process, and I'm gonna do it by taking away water from the big bucket first. And so, how many steps does it take to get to 2? Well, if I kind of did it naively, I might think, okay, I'm going 10 to 7 to 4 to 1 to 8 to 5 to 2. That's 6 steps. So that should take 12 steps. Plus, I go around I go around 0 once. So that's an extra 2 steps. So it should take 14 steps, right? So let's try it out. I'm going to transfer the water, empty, transfer a few times, transfer. Now I fill this up again before transferring, and keep going, and get down to 2. Okay, great. So no problem. 14 steps. That's fine. Now what about the other way? So if I go the other way, now this is the faster way actually. I'm going 3, 6, 9, 2. So it's only 4 steps. So that should take 8 steps plus the extra 2 from going around once. And so that should give us 10 steps, right? And that's almost right. So if I fill up the small bucket and start transferring it, I will get over to 9. But now what happens here is once I transfer 1 more gallon here, I end up with 2 gallons in the small bucket. Right, I end up with 2 gallons in the small bucket. So it actually only takes 8 steps to get there. I don't have to worry about those extra 2 steps from emptying the big bucket and transferring it over because I don't actually need to get the water in the big bucket. I can get it in the small bucket. And the reason that works, I have to think about that with 2 and not for some of the other numbers, is that 2 fits in the small bucket, whereas the number 5, which is the number we were trying to get to in the main puzzle, does not fit in the small bucket. So I don't have to worry about that. Now, in the extra credit puzzle, 50 definitely fits in the small bucket, so I do need to worry about that. So let's think about going at it from a certain direction. So I'm going to think about this going kind of down. So if I go, well, I guess I'm going up. I think for some reason, because it's 7 instead of 93, I think of that as the increment, but it's really an increment of 93. So if I'm starting at 57, I'm going up, I'm adding 93 each time. So that's the 49th number in this chain. And to get 57 in the big bucket, right, it's going to take, there's 49 steps times 93 gallons in each bucket. So that's 45, 57. So I will get 57 gallons in the big bucket. And that'll take 49 times 2 steps because there are 49. I'm filling up the small bucket 49 times. And then I'm emptying the big bucket 2 times. That's 188. And so at this point, I've got the big bucket with 57 gallons in it and a small bucket with 0. And then what happens if I keep going? Well, so that's a step number 188. The next step is to fill the small bucket up. And now the next step is to pour the water from the small bucket into the big bucket, which gets me to 50 in the small bucket. And I could take those 2 more steps, be at 192, to fill up the big bucket, to empty the big bucket and then fill it with the 50 gallons, but there's no reason to do that. I can have 50 in the small bucket and that works just as well. So it actually takes 190 steps, not 192, to get there. And if I go the other way, it doesn't work because if you think about, well, the reason it doesn't work is because when I do the strategy where I empty the big bucket with the small bucket, there's really never a point where the small bucket has those 50 gallons in it. Um, Now it's hard to see with with this version, but I mean so here I get one in the big bucket, and now when I start doing this transfer, now when I transfer, now I get one in the small bucket, but there was already one in the big bucket before. So there's no point in which the small when I do it this way, where I empty the big bucket with the small bucket, I never get a point where a number appears in the small bucket first. Even a number like one, where I could get there with the small bucket, it happens in the big bucket first. So we don't have to worry about that direction having a faster way. So anyway, that's it. That's the puzzle. Hope you learned something and hope you had a good time, and I'll see you next week.